everybody, welcome to this Java tutorial. Today we're going to continue our study of linked lists, and today we're going to take a look at circular lists. A circular list is interesting in that it still has an external pointer, which allows us to start processing the list from the first node, but also the last node in the list points back to the first node in the list, allowing it to exhibit this circular behavior. Now, a circular linked list might be used by an operating system when it's performing round-robin scheduling. Every process in the list is given a fair amount of CPU time, and we just visit each process again and again and again until the processing is done. Of course, processes can be removed from the list and inserted into the list as well. Today we're going to look at a linked list of car objects. So let's get started. Now, as I said, the data in each node is going to be a reference to a car object. So I have designed a very similar simple car class, just with one attribute, one constructor method, and an accessor method for that private attribute. Okay, let's keep it simple. Of course, every node has a pointer to the next node in the list, as we saw before. And what I'm going to do when I construct a node is just set that next pointer to be null, as we have been doing so far in this tutorial series. And there's nothing new in this design of the node class. Of course, getData is returning the reference to the car object. Okay. All right. What we're going to do today is look at how to add a node to a circular list and how to display the list. Okay. As before, we're going to use a global variable to represent the root external pointer that we've got here. And when we jump into our program, we're just going to set root to be null. We're then going to create a car object. And we're going to try and call this function here, add to list. And we'll send it that. We don't want to send it the car, do we? We want to send it the node. Sorry. We're constructing nodes, not cars. But the node needs a car. So let's just do that again. Apologies. So n1 equals new node. And the constructor method needs a car object. Okay. Okay, so let's send it n1. Okay, so we're trying to add this node to the list. Now let's go into the function and let's see if we can design it. This is the node we're going to be working with. Check if the list is empty, because that could be true, right? So if root is null, so if root is null, we're going to take this node, this is the new node, and we're going to say root is assigned to new node. But also, if this is the first node in the list and the only node in the list, its pointer is going to go back to point to root, because that's the nature of a circular list. Even if we've got one node in the list, its next pointer is going to point to root. Okay, so new node dot set next root. Okay, and when we've done that, we're just going to return out of the function, and we've finished. We've inserted the first node into the list. Now, if that's not true, it means we already have some nodes in the list, similar to this situation here. And let's say we've got a new node here, Audi. We're going to try and insert Audi into the list. Okay, so we need to search for the last node in the list. So let's create a search pointer. And assign it to whatever root is pointing to. So we've got a search pointer here pointing to the first node in the list. Now remember, what we were doing before was saying while search pointer dot get next doesn't equal null, we're going to do something. But this time there is no null, because the last node in the list doesn't point to null. It points back to root. Okay? So while search pointer dot get next doesn't equal root, we're going to update the search pointer. Okay, so search pointer starts here at Honda, while search pointer dot get next doesn't equal root. That's true. Search pointer is going to jump to the next node in the list. While search pointer dot get next doesn't equal root. That's true. So we're going to jump to the next node in the list, while search pointer dot get next doesn't equal root. Yes, it does. So this is where we finish. Search pointer at the end of this loop, search pointer is now visiting Toyota. Okay. Now that we've found the last node in the list, we want its next pointer to point to the new node. This is going to point to the new node. And we want the new node to point to root. Okay. So search pointer dot set next. The search pointer is here, and we're going to set the next to the new node. And the new node dot set next is going to go to root. And that's it. We've just inserted a node into the end of a circular linked list. Okay. Now, before we finish this video, let's just very quickly consider the display list function, because it's probably a little bit different to what we've seen before. Okay. So to display the list, I want to see the name of each car, the model of each car. Was that right? It was model, wasn't it? Yeah, model. I want to see the model of each car. So I'm going to create my search pointer, which is a node, of course, a node reference. And I'm going to assign it to root. While search pointer doesn't equal null. There is no null unless the list is empty. In fact, we need to do that, don't we? Let's do the empty check. We're just going to say empty list. We'll just return out of that function. Okay. But if that's not true, it means we do have at least one node in the list. But we can't do this because there is no null. Okay. So could we do this? While search pointer doesn't equal root, well, when search pointer does equal root, because what we want to do is this. Search pointer dot get data, which returns a reference to a car object. This is a reference to a car object. So now we can call car class methods. Okay, that will display the model of each car in the list, and then we want to update search pointer like we did before. But this won't work while search pointer doesn't equal root. Well, it does equal root. Because we just said that, search pointer equals root. So this while loop is never going to run. That's a problem. Pause the video if you want to solve that problem, but I'm going to tell you a very neat trick to get around that, okay? Okay, here's the trick. Don't use a while loop, use a do while loop. Can you see how that works? We set the search pointer to root. If there is something in the list, we print out that search pointer's model, which is Honda, and then we update the search pointer. So search pointer equals search pointer.get next. So we jump to here. This is the new location of search pointer. And then we do the while check. While search pointer doesn't equal root. Well, that's true. Search pointer doesn't equal root anymore. We've moved. Okay? And we just keep doing that until we get back to root, which is where the while condition will terminate. So have a think about that. See if you can figure out how to insert a node at the end of a linked list and how to display the data at each node in the list.